In this video, we're going to take a look at the mean and variance of the binomial distribution. Now, let's say we have a random variable x. So if x is a random variable and x follows a binomial distribution with parameters n and p, let's just write that down in mathematical notation to begin with. Like we said, we've got x here, that's our random variable. This follows a binomial distribution with parameters n and p. Then the mean of this random variable x here, let's just write this down. The mean of the random variable x here, this is the same as the expectation of x, so this is e of x, the expectation of our random variable x here, and the Greek letter that we use here, remember, just to represent the mean, that is simply mu. So mu here for the mean, that is simply equal to np. That's the parameter n times by the parameter p. So that's the mean of our random variable x. Now for the variance then, again, let's just write this down. So for the variance of x here, this is var x. Remember, for the variance here, the Greek letter that we use is sigma squared. We've got sigma squared. And this is equal to np. Remember, np there, that's the mean, so it's the mean times by 1 minus p. Okay? That gives us the mean of our random variable x here. So if x follows a binomial distribution with parameters n and p, the mean is given as np, and the variance is given as np times by 1 minus p there. So that's everything that we need there for the mean and variance. Just a quick point here, these results are given in the formula book, so you don't actually need to worry about memorizing these results, although they are pretty straightforward. I don't think there's anything too challenging here to actually memorize. Like you can see, pretty straightforward results. So what we're going to do now is just take a look at some practice questions here for the mean and variance of the binomial distribution. Starting off with question 1 here then, we're being given the random variable x, which follows a binomial distribution with parameters of 20 and 0.4. So we're asked to find two things here. For the first part, we're simply looking for the mean of x. So our random variable x here, we already know that follows a binomial distribution, so we can simply use the results that we established at the beginning of this video. So for the mean of x, let's just write this down in full. So for the mean of x here, well, just remember this is simply the expectation of the random variable x. That's e of x. E of x, which is equal to the mean, so it's just mu, the Greek letter mu there, representing the mean. And in this case, the result that we established is n, our parameter n here, times by the parameter p, so it's np there. Okay, so like we said, n is 20 here. Write this down, n equals 20 equals 0.4 there. So nice and straightforward here, we get 20 times by 0.4 there, and 20 times 0.4 simply gives us 8 there. So the mean of the random variable x is equal to 8. And that's part A done. So like you can see, quite straightforward just using these results here. That's part A done. Now for part B, we're looking for the standard deviation of the random variable x. So for the standard deviation, just remember the standard deviation is equal to the square root of the variance. So the standard deviation then, again, let's just write this down in full. The standard deviation of x for the standard deviation of x, this will be equal to the square root of the variance of x. So this is equal then to the square root of the variance of our random variable x there. Okay. Now for the variance of x, again, we established this result here at the beginning of this video. So let's just write that result down again here. The variance of x is equal to np, which we've already established in part A, so it saves us a little bit of time there. And then we times that by 1 minus p there. Okay. So in this case then, the variance of our random variable x, that would be np, which we already know is 8. So we get 8, and then we times that here by 1 minus p, where p is equal to 0.4. So 1 minus 0.4. So in other words, what we're doing here is 8 times 0.6, and what that gives us then is 4.8. The variance of x here is 4.8. But don't forget what we're actually looking for here is the standard deviation of x. So we're looking for sigma. So sigma here equal to the square root of the variance of x. It'll be the square root of 4.8. If you put the square root of 4.8 into your calculator and give it to a sensible degree of accuracy, in this case, I'm going to give this to 3 significant figures. What I get then is 2.19. Okay, so 2.19 there. And there we have it. So that's the solution to part A. So the mean of x is 8. And we have the solution to part B here, where the standard deviation of x is 2.19. Moving on to question 2, now we've been given the random variable y, which follows a binomial distribution, such that y is binomially distributed with parameters of 15 and p. We're also given that the variance of y is equal to 1.35. So for the first part here, part A, we're to find the possible values of p. So for part A then, we're looking for the possible values of p. So what do we already know here? Well, we know part of the distribution that y follows, so it's binomially distributed. Binomially distributed. We know n equals 15, so let's just make a note of that here. N equals 15. Obviously, we don't know what p is. That's what we're looking to establish here. Okay, so we've got p here. And we also know that the variance of y is equal to 1.35. So for the variance of y, that is equal to 1.35. Now, because we know what the value of the variance is here, so the variance of y is 1.35, what I'm going to do here is use the result for the variance that we know, that we established at the beginning of the video. So the variance of y in this case is simply equal to np times 1 minus p. Now, if we know n, we can substitute that in here. That is equal to the value of the variance that we know. So we know the variance of y is equal to 1.35, and we should hopefully be able to solve this equation here, okay, and find the possible values of p. Like we said, we know that n is 15. So what I'm going to get here is 15p times 1 minus p here, and that is equal to 1.35. Like so. So what we can hopefully see here is that we're going to obtain a quadratic equation in terms of p. But before I expand anything here, what I'm going to do is I'm just going to divide both sides by 15. It'll just make life a little bit easier here. On the left-hand side, we simply get p times 1 minus p. We divide through by 15. On the right-hand side here, 1.35. Divide that by 15. And what you will get is 0.09. Like so. So from here, what I'm going to do now is expand this left-hand side. So p times 1, that gives me p. P times minus p, I get minus p squared. And that's all equal to 0.09. What I'm going to do here now is take everything on the left-hand side over to the right-hand side. And what that will do is it will just make the p squared positive. Just makes it a little bit easier to work with. So what I'm going to get then is we get p squared. I'll get minus p because this is positive here. So minus p, this is already positive, so plus 0.09. And that now is all equal to 0. We've got a quadratic equation here set equal to 0. So what we always want to check here is whether we can factorize this quadratic equation. And in this case, we can indeed factorize this result. So what I'm going to get here then is double brackets. You could just use your calculator as well just to factorize this if you find that a bit easier. But what I'll get then is p minus 0.1, like so. I'll get p minus 0.9 there, okay? And from here, we can solve this now to get the two possible values of p. Therefore, p is going to either be equal to 0.1, or p is equal to 0.9, okay? And there we have it. So that gives the possible values of p there, giving us a solution to part A. So for B then, for part B, we're given a bit more information here. We're given that p is strictly greater than 0.5. So this condition here is important because it now means we can eliminate one of the values of p here, and we're going to eliminate this value of p here. So p can't be equal to 0.1 in this case. It must mean that p is equal to 0.9. So in this case then, we have our distribution. So y follows a binomial distribution. We have parameters then of 15 and 0.9. But in this case then, we're simply looking for the expectation of y, in other words, the mean of the random variable y. But in this case then, expectation of y, we already know, nice and straightforward, this is simply the parameter of n times by the parameter p. It's going to simply be np, and like we said, nice and straightforward then, it will simply be 15 times 0.9, that would give me 13.5 there. Okay, and there we have it, so that's the solution to B, that's the solution to A, and that gives the solution there to question 2. And finally then, if we take a look here at the very last question, question 3, we've got this question now in context. So what we've got here is an electronics company that produce light bulbs. The probability that a light bulb is defective is 0.02. The company produces 200 light bulbs a day. They're asked to find the mean and variance of the number of defective light bulbs. What I'm going to do here to begin with is establish my distribution here. It doesn't really matter what letter we use to, choose our random variable, whether that's x, y, completely up to you. I'm just going to use x here to represent our random variable. So x follows a binomial distribution in this case. N in this case would be 200. That's how many light bulbs they produce a day. So n is equal to 200. My probability here is the probability that a light bulb is defective. So it would be 0.02. Okay. That gives the distribution that we're working with here. Okay, like I said, it doesn't matter whether you choose x, y, z, completely up to you, but the standard kind of thing we do here is just use x. Now we're looking for the mean and variance, so again, we're choosing the results that we established at the beginning of the video. Let's just write these down. So for the mean here, that's the expectation of x. That is the Greek letter mu. And that is simply np. And for the variance then, that is var x, and that is sigma squared, and that is np times 1 minus p there. Okay, so for the mean then, let's just begin with the mean. Nice and straightforward. So mu here, the Greek letter mu, it's np. In this case, like we said, n is 200. So let me just write this down over here. Therefore, n equals 200. And p is equal to 0.02. So in that case, n is 200. And by p, which is 0.02. And in that case, 200 times 0.02, that simply gives us 4 there. Okay. So for the mean then, we get 4. Now for the variance, is sigma squared. Like we said, it's simply np times 1 minus p. np times 1 minus p here. Now we already know what np is. We established that with the mean, because np gives us the mean there. I get 4 times 1 minus p, where p is 0.02. What I get here is 4 times 0.98, and 4 times 0.98, that would give us 3.92 there. Okay, and there we have it. So the mean then, the number of defective light bulbs is 4, and the variance, the number of defective light bulbs is 3.92. And there we have it. So that is the solution to question 3. That brings the end of this video on the mean and variance of the binomial distribution.